should be there, what should I expect from this run. Just looking at that pattern in real time, you will form your conclusion that yes, my library is okay. Yes. You can try to salvage your library by doing some wash and everything. So we'll again keep the chip with water for wash. And this is again a used chip to be thrown away. Coming to the results. First, we have sample of letter. So over here in DNA 1000, the lower marker is of length 15 bases, upper marker is of length 1500 bases, and you have your ladder peaks in between 25, 50, 100, 150, 200, 300, 400, 5, 7, 8, 50, and 1000. So this is the expected pattern of ladder. If you are seeing something like that, that means your bioanalyzer, chemicals and reagents and everything was okay. Every peak is there, that means everything is run fine. Still, if you find some issues with sample, that means there was issue actually in your sample, but not with the bioanalyzer run itself. So by default, what happens is it detects the fluorescence unit and across the time. That is, it knows that around 45 seconds or 43 seconds there will be a peak. Then it observed a peak around 47, 45 or 46 seconds, 48 seconds. And then it tries to detect wherever there is peak. So this green line indicates that it has found a peak at this particular position. So whatever pattern it is seeing, it is detected as a peak. By default, this red line is the fluorescence signal. And using that signals, wherever it detects the peak, it will give you by this green line. Bottom is timeline, but since we have ladder with us and we know all of them, we can convert it into base pair. Time can be converted into base pair based on the ladder information. And since markers are also added in all the pairs, we know the relative position of 15 and 1500. So therefore, over there also using that information, they can be converted into base pair. Then it also gives you the concentration of each peak. Whatever peak they are detecting, they will give you the concentration. The software has predefined sets for them. And if we are using DNA 1000 and you have loaded DNA 1000 ladder, so all of these peaks are having so and so concentration. So what happens is, when I am talking about concentration, nanogram per micron, also depends on the length of fragment. For example, I am having a 1000 base pair fragment and I am having a 100 fragment. Which one is going to have more weight? 1000. So when I talk about nanogram per microliter, which one is going to have more concentration? 1000. Even if I have one fragment of both, that one will be having more weight. Right? So therefore, if you have same concentration for all, you will have varying peak size. Because number of fragment needs to be varied. In most cases, when I say that I have equal concentration of small fragments and larger fragments, that means that number of fragments in this smaller one will be more. And that is this one means this one. Okay, we'll come to that. This is the by default image. That based on that, they also give you size and concentration and molarity and everything. Similarly, when we see for all the samples, you will see that marker peaks are detected, which is say 15 and 1500. Compared to that, they have converted the time into base pair. Now, wherever there were fragments, the fluorescence will rise, and therefore there are peaks which are formed. If you see that tried, they have some threshold that what particular pattern to be called as peak. So over here, it has identified this as two separate peaks, this as a single peak. While over here, this is not detected as peak. Yeah, because it has some sort of its own threshold. How much width should be there, how much height should be there, and everything, area covered and almost. Similarly, if you see over here, there is a small peak, but it won't be detected because area covered by that peak is very much less.
Even though we have added in a first one the ladder, only the two peaks of 500 and
No. This is marker. Lower marker and upper marker. Right. So what this bimarker also allows us to do is add and delete the peaks, detected peaks as well. Sometimes it may happen that the upper marker or lower marker is not detected. In that case, you can manually say to the image that this was my lower marker, this is my upper marker, and calculate the size according to that. Right. It gives us flexibility. We have to change the assay. We cannot do DNA 1000. We need to do DNA HS.
different.
So for 16S metagenomics, we have final library size of around 630 base pair. Over here, in case of AMR panel of AmpliSeq, we have the library size ranging from around 175 or 200 bases to almost 500 or 600 bases, something like that. Yes, this is sample. So in most, for both AmpliSeq as well as 16S metagenomics, we use DNA 1000 XL. For shotgun metagenomics or WGS or any of the shotgun applications, this range is quite broad. It starts from 200 and can go up to 2000. So for that purpose, we use high sensitivity DNA. Over here, all the peaks that it has detected, it is showing you concentration and the molarity of each peak.
Can we interpret it is having four amplicons of different sizes?
We cannot say four amplicons. It could be multiple amplicons of the same size as well. So over here you can say that amplicon of size 402 is more as compared to 480. But then again, to make that comparison, you also need to consider the length of the fragment also. Therefore, we look at the molarity. So, if we look at sample C, so over here the pattern is different because number of the sample was different, and therefore AMR genes might be different.
Different and concentration.
So concentration you can compare it with what you have seen on the qubit. So what you have seen in qubit will also be reflected over here, right? Then
So by seeing this results itself, we can say that few AMR
there might be two chances. So for in case of 16S metagenomics, you will be getting only a single qubit, right? So whatever concentration you are seeing on qubit belongs to that single peak only. Over here, whatever concentration you are seeing belongs to multiple peaks of different sizes. So that distribution is it is reflected, but it is not exactly reflected as much as in case of 16S metagenomics.
So using the AMR panel, the diagnostic, we can say that if it is 3 not 6, we can say it is particular and class of multiple.
No, never. Multiple amplicons can have same size. Therefore, we are doing sequencing and not looking only in bioanalyzer.
Just 400.
Therefore, we are wasting one 1.52 lakhs and not only just 7,000 rupees.
But in whole genome sequencing, it will be like the 16 as the only single page.
Broad peak. I'll show you the. Now, all of them are having almost different but in a similar range. Finally, if we look at the blank one, right? So since we are yes,
There's no cross contamination.
I can share this PDF with you, no problem. But the main thing was that in the blank, we should only get 2 peaks of markers, lower and upper.
They
That,
are like controls.
yes.
Ladder and bank.
So this is the entire flat line that we should get in case we are not getting it.
What about that?
So this is the just a summarized view of all the samples and ladders. Now this was a electropherogram. If we click on gel image, this is what agarose gel will look like. So if you see that there were few small peaks, nature quality picture. But then again, if you look over here, this 400 base pair, it is present in all. Then over here we have 2, more than 300 and a little bit lesser than this is present here, here, here. So since your targets are same, even though your sample might be having them or not, that can be reflected. Third and fourth.
Are very distinct, but other ones they are somewhat.
Apart from that, you may be having other
That's what.
fragments, other-
So now what we are going to do is not Illumina, the finalize agent. So what we are going to do is, since there are multiple fragments of different length and everything, we are going to take an average size of the fragments. Okay. So we had all those samples. Even we can look at this way. These are all the fragments overlaid on each other. So you will be able to see that few of those peaks. Yes.
So our fragments are good.
Best.
Success. All sense.
So now we need to look at the average library size. So currently it is showing you the peak tables. Then over here we have something called region table. And we add a region.
Our sense of
Yes. This much region is my intended region. I will keep somewhere around 175 to 500. Because I know that what my fragment size should be. So over here it will say average size is 329.
So when the primers are given by the company, they will tell how much the minimum size
Yes,
is.
your entire design is shared with you. That what target was there, what is the name of that target, the sequence of that target.
Size.
So if you have the sequence, you can very well know the size and everything.
So based on that, we are choosing the region.
Example, beta section,
And even this implicit design, they suggest that if you are not comfortable with your average library size, you cannot estimate based on differences in different samples. Take 330 or 360 as average size because they are trying to design your library, your targets in such a way that this counts as your average library size. Not too big fragments and not too smaller ones. Ours is 329. But since we can have some bigger fragments, so it may vary. Now this same exercise I will perform for all the samples. Over here also I will go till 500, and you will see that there are few fragments which are having bigger. So that may be coming from two successive primers. They are over amplifying our
But that should
product.
have been removed during this.
Nothing is entirely accurate. Even if I have taken just a little bit of beads while library prep, this will be reflected here. So over here my average library size is 357. So in this way I will do the region, add region for all the samples, consider their average library size for each and every individual samples. Now when we are running 96 samples for 16S metagenetics or AmpliSeq, we cannot run bioanalyzer for each and every sample. So what we try to do is repeat them based on their average size. We take the average of their average size, use it for all our further calculations. In case of shortened metagenomics or WGS library, since all of your library is going to be different, it is unique for each of them. Therefore, we need to run each and every WGS library on bioanalyzer, take the average library size for each of them, and use that for downstream
For
calculations.
this AmpliSeq also, if the bacteria are different,
Yes,
totally different microbial population, there also you will find
we'll find it. But since we cannot do for more samples, therefore we try to consider the
even at the community profile here.
Yes. 356. One more thing that we need to take care over here is to check for the presence of primer dimers. Most of those primer dimers will have length around 35 to 50 bases. Right? So we should not get any peaks near the lower marker, which is for 15 marker. All those type of quality checks can be very well performed through bioanalyzer.
integrity of the fragments.
We don't need to care. So bioanalyzer only gives you the pattern of fragments. So how much length, which fragments, what fragments of what length are in what proportion. These fragments of this size are more in number compared to fragments of this size.
There is another instrument which is called
Agilent tape station.
Tap.
Tape. TAPE. So it is somewhat similar to bioanalyzer. Both were prepared by the even same manufacturer even. So I will share these results can be exported in PDF. So I will be sharing that PDF with you all in the group. We will